Hi, I'm Richard Gerber from NERSC Supercomputing Center at Berkeley Lab. I'm the High Performance Computing Department Head and the NERSC Senior Science Advisor.
Welcome. Thank you for joining me in this video to talk about COVID-19 and HPC and the best practices and the work that your center has been doing around this. So can you tell me a little bit more about how NERSC is working to solve the problem of COVID-19?
Sure. So let me first say that we're really pleased and happy that we're able to provide some resources to researchers at the kind of scale and complexity that they wouldn't otherwise have access to. Our mission at NERSC is to support research in the U.S. Department of Energy Office of Science, but we get about 10% of the time at our center that we can give out at our discretion to strategic projects or interesting science projects. And of course, nothing really has been more important than COVID this year. So we've used most of that time to give resources to researchers who are specifically looking into solving some aspect of the COVID-19 pandemic problem. And so we've been able to give out about 2.5 million node hours, or that's about 200 million kind of core hours in this NERSC hours unit that we use. And so we're really glad to be able to do that. And at the same time, we've got a little bit of funding from the Department of Energy to support some staff time, some staff expertise to help the researchers use our center. And so we've been able to do that. So those are the primary ways that we're doing it.
Do you have any examples of projects that are leading this subject at NERSC?
Sure. We have about 20 projects that are specifically allocated to work on COVID problems, and they range from many different things, like epidemiology studies to a fair amount of atomic and molecular scale modeling to try to model the virus and its interactions and its structure. Seeing a lot of drug screening, for example, some AI-informed diagnostics of X-rays and CT scans of lungs and that sort of thing. One of the researchers, Wayne Ching from University of Missouri, Kansas City, performed a modeling of the structure and the interactions between the virus spike protein and the ACE receptor on the human cell at a level of accuracy that hadn't been done before. And so he was able to do that quickly, repurpose his research to that. And it was actually our first refereed publication to come out of this effort. And it was featured on the cover of the journal PC CP with a big picture and a big splash. So that's one way to determine that things are high profile when people in the field are highlighting the research. A number of projects that are screening pre-existing drugs to see if they have any usefulness in helping destroy either the life cycle or the binding of the virus. And some of them have finished their initial scans. So there are so many possibilities that experimentally it would take forever to actually study them all. So they do it computationally. And then they take those results and move them into the lab. So there are a number of projects that are in that stage now, that are in the lab stage, looking to test drugs that could be used against the virus. And one of the advantages of using pre-existing drugs is that they're already in use, so their safety has been determined. And then a final example was a large epidemiological study used by the U.S. Department of Health and Human Services, actually, to try to model how various mitigation strategies might work in spreading in how the virus spreads. So what they were able to do using the scale of resources that we have is do a whole nation, a whole U.S. study at the county level. So they're looking at interactions among individual counties in the U.S. and how various things that you could possibly do to mitigate the viral spread or infections would play out in a national kind of scene.
Awesome, thank you. And that, I think that kind of leads me to my next question, where you've talked about, for example, how the use of existing drugs and using HPC to analyze them and kind of work them into a solution for COVID, mapping out those proteins. They're all reliant or maybe not reliant, but they all used HPC because of how much it can accelerate their work and give them the speed to do things. So can we talk a little bit more about how HPC has enabled and accelerated the research that's going on at NERSC?
Sure. Again, it's really the kind of the scale complexity of the resources that we have that's given researchers access to something that they didn't have access to before. And in addition to that, there's really an aspect of this that, and I mentioned it briefly before, is really helping them get on the system. So for each of these 20 projects, we've identified a staff liaison to work with them. And as many people who've tried to use HPC know that it's trying to scale up a problem you might be running on your desktop or even on a small cluster and immediately run them at a big HPC center. Has a number of challenges that you really wouldn't think of ahead of time, but this whole new level of complexity and various other things come into play. So our staff has been working very closely with these researchers to get their jobs to run, their workloads to go. Sometimes they needed special software that needed to be compiled and built to run in parallel and this sort of thing. So that's really been something we've been able to contribute to, and it's really nice that we're able to do that.
And so you've mentioned, researchers coming together, the HPC providing a central space for them to work. Can we talk a little bit about how, as we are in a pandemic, basically the sharing of knowledge and collaboration is probably more important than ever. What initiatives are you involved in to help accelerate and advance COVID-19 research in the name of knowledge sharing and collaboration?
Right. So the collaboration question is really interesting. We're a big center. We have 7,000 to 8,000 users and about 1,000 different projects. So we have a very diverse community. We're also part of Berkeley Lab, which is a DOE Office of Science lab that does research in many, many different areas. And we're also very close to UC Berkeley. We're right next to part of the UC system. So we have many, many collaborations kind of going on all the time. And we're able to leverage a lot of those. A lot of the projects that we have come in through as an offshoot of these various collaborations. I can name a couple of them, and I will in a second. But there are some other collaborations that have been set up that we are also working with. One is in the US, we have a national COVID-19 HPC consortium. That's a partnership of public, the Department of Energy, the National Science Foundation, and NASA is part of it too. NOAA may be part of it, and a lot of educational institutions, but also cloud providers and the private sector. That evaluates proposals and gives out time to researchers time and assistance to researchers who need the power to be able to do their research. So we're part of that consortium. We're very active in that. We're also part of this C3 AI Digital Transformation Institute, which is a research collaboration to use AI and other methods to solve various problems, societal problems. And of course, this is one of our biggest ones now. We also have a couple of projects that we're collaborating with that are part of the exascale computing project in the US. And then I said we have a lot of other collaborations that kind of grow organically out of existing collaborations. So I'll give you a couple of examples. So one project that's very interesting that's kind of maybe unusual is this project called COVID Scholar. And I don't know if you've heard of this, but it grew out of some work that a group of material scientists at Berkeley Lab had actually done to try to use AI and natural language processing techniques to be able to quickly find research in their field that they were interested in. So it was kind of a souped up literature search with many, many different ways of gathering data. So they'd actually published a paper in Nature describing this. So it was a very high profile effort. But then when COVID came along, they said, hey, can we apply this to COVID? Because research is going on all over the place. It's being published in journals, but also very quickly in other non-traditional areas. And so it's hard to find all this information. So what they did was they very quickly, because they've been working with us already in other areas, set up a pipeline or a workflow to be able to gather the information, run daily their their AI natural language processing algorithms on Corey, and then take those results and set up a database and web portal on our Spin. We call it an internal cloud, but it's an edge services that has good connectivity to Corey, and put up this portal of which they also have an API called COVID Scholar. So if you go to covidscholar.org, I think it is, you'll find it. And so that's been much used. It's had tens of thousands of users from all over the world that have been using it to get access to the latest research in COVID research. And it's also being used with other efforts at Pacific Northwest National Lab, for instance, and the MIT Rapid Research Journal is making use of COVID Scholar too. So that's one thing you might not think of initially when you think of COVID research, but this is something that we've certainly been able to do, and I think that's been a great use of our resources.
Awesome, cool. Thank you for those examples. I really liked the COVID Scholar that you mentioned, because it's a very different way compared to the a few other centers that I've been talking about that share a lot of the databases and the research that their users are doing. A lot of the conditions of the accelerated programs are to publish the data onto this database even before their papers have been published, that there's a dissemination of this information. But I really like this Scholar and how it can potentially even identify gaps in the research that's been going on with COVID, and then allow researchers to come in, identify those gaps, and begin a project on that. So that's a very cool initiative. Yeah, I really like that. I just wanted to thank you for your time and for joining me on this video newsletter.
Okay, well, thank you. I mean, I think it's really, like I said, it's really exciting and a privilege to be able to take our work and apply it to pressing needs or pressing problems that can kind of help everybody and help society in general.